Huawei is very dangerous.
Rarely does a country go to war with a private company.
We have met the enemy, and it is Huawei.
We're not going to do business with Huawei.
Huawei represents a national security risk.
But is this really about Huawei, or is it something bigger than that?
December 6th, 2025. A patent filing surfaces that makes semiconductor executives around the world stop breathing. Huawei, the Chinese tech giant that's been locked out of advanced chip-making equipment since 2019, just published a detailed blueprint for manufacturing 2-nanometer chips. The same cutting-edge technology that TSMC, Samsung, and Intel have invested over $100 billion developing. Except Huawei claims they can do it without the $150 million machines they're banned from buying. Some analysts are calling it impossible. Others are quietly wondering if the global chip war just took its most dramatic turn yet. To understand why this patent is seismic, you need to understand the technological cage Huawei has been trapped in. In 2019, the United States banned Huawei from purchasing chips manufactured by TSMC in Taiwan. Then in 2022, the Netherlands blocked ASML, the only company on Earth that manufactures EUV lithography machines, from selling to China. These EUV machines are the absolute gatekeepers to advanced semiconductor manufacturing. They cost over $150 million each, require operation in a vacuum, and use light with a wavelength of 13.5 nanometers to etch microscopic patterns onto silicon wafers. Without EUV, the entire semiconductor industry believed you simply could not manufacture chips below 7 nanometer. This was considered fundamental physics, not a technical challenge, but an actual barrier. Only TSMC, Samsung, and Intel possess these modern EUV machines, giving them an insurmountable advantage in the race toward 2-nanometer and 3-nanometer process nodes. But here's where Huawei started breaking the rules everyone thought were unbreakable. In 2023, they released the Kirin 9000's processor, a 7-nanometer chip that wasn't supposed to exist. Western analysts had written off Chinese chip making as stuck at 14 nanometers or worse. Then in 2024, the Kirin 9030 pushed toward 5-nanometer equivalent performance. Each time experts said impossible, Huawei and their manufacturing partner SMIC proved them wrong. They were doing this with older EUV lithography machines, deep ultraviolet technology that uses light with wavelengths of 193 nanometer or 248 nanometer. To put this in perspective, that's like trying to write with a marker that's 10 times thicker than the lines you're trying to draw. The physics shouldn't allow it. Yet, somehow, they're making it work. Now, this patent filed back in June 2022, but only published on December 6, 2025, by China's National Intellectual Property Administration, lays out their roadmap for 2-nanometer manufacturing. The document is titled Metal Integration Method for Manufacturing Integrated Devices, and it describes something called self-aligned quadruple patterning, or SAQP for short. Instead of using EUV to draw ultrafine patterns in one exposure, Huawei's method uses DUV machines to build up the same patterns through multiple, carefully orchestrated steps. Think of it like this. EUV is drawing a thin, precise line with a fine tip pen in one stroke. SAQP is drawing that exact same line by making 4 separate passes with a thicker marker, using stencils and spacers to guide each pass with atomic precision. The patent specifically describes using 5 spacer layers and multiple metals, including ruthenium, copper, and cobalt, to create self-aligned metal interconnect spaced less than 21 nanometers apart. The brilliance and the gamble of this approach becomes clear when you look at the numbers. TSMC currently achieves yields of around 90% on their 7-nanometer process using EUV technology. That means out of 100 chips they manufacture, 90 work perfectly. SMIC using DUV multi-patterning for 7-nanometer chips achieves only 50% yields. At 5 nanometers, their yields drop to around 30%. This has massive cost implications. Each Chinese manufactured chip currently costs approximately 40% more than an equivalent chip from TSMC, even with Chinese government subsidies covering roughly 30% of manufacturing costs. Now imagine pushing this complex multi-patterning process to 2 nanometers. Each additional processing step is another opportunity for defects. A single speck of dust, a microscopic temperature variation, a chemical impurity measured in parts per trillion. Any of these can ruin an entire wafer. Industry analysts estimate that initial yields for 2 nanometer chips using this method could be as low as 10 to 15%, making each successful chip extraordinarily expensive. So why would China accept these astronomical costs? The answer is written in the language of technological sovereignty. The Chinese government has poured tens of billions of dollars into semiconductor independence, viewing it as a matter of national security rather than simple economics. This isn't about making the most profitable chips today. It's about ensuring that in 10 years or 20 years, China isn't held hostage by foreign technology restrictions. The state can subsidize inefficient production indefinitely if it means achieving self-sufficiency in the most strategically critical technology of the 21st century. Let's compare Huawei's approach directly to what TSMC is doing. TSMC's 2 nanometer process entering mass production in 2025 uses advanced EUV lithography with high numerical aperture optics and gate-all-around transistor architecture. They've spent over $40 billion on research and development and new fabrication facilities. Their approach is proven, reliable, and will likely achieve 85 to 90% yields from the start. Huawei's path uses older DUV equipment that Chinese companies can still access, combined with extraordinarily complex multi-patterning techniques. It's riskier, more expensive per chip, and unproven at scale. But if it works, it doesn't require the $150 million machines that China is blocked from buying. The geopolitical implications ripple far beyond semiconductor specifications. TSMC controls approximately 60% of the global foundry market and nearly 90% of advanced chip manufacturing. Their customers include Apple, Nvidia, AMD, Qualcomm, essentially every major technology company. If Huawei successfully manufactures competitive 2 nanometer chips, even at higher costs, they could supply China's enormous domestic market. That's 1.4 billion consumers, companies like Xiaomi, Oppo, Vivo, BYD, Alibaba, and ByteDance, plus government and military applications. We're talking about potentially 30 to 40% of global semiconductor demand shifting to Chinese foundries. For TSMC, losing access to Chinese customers would represent a massive revenue hit and could fundamentally reshape the global chip industry into 2 parallel ecosystems. But here's the critical reality check. Having a patent is one thing. Manufacturing millions of flawless chips is entirely different. The patent shows serious engineering work and genuine innovation, but it's not proof of production capability. We have no evidence yet of actual 2 nanometer chips being manufactured at any scale. The timeline from patent to mass production typically takes 5 to 7 years minimum, potentially longer for such a complex process. Huawei would need to build an entire ecosystem of ultra-pure chemicals, specialized photoresists, advanced inspection equipment, and thousands of trained engineers who understand these processes. TSMC spent 30 years and worked with over 600 suppliers globally to build their capabilities. So, is TSMC actually in trouble? Not in the next 2 to 3 years. Their technology leadership is secure, their customers aren't going anywhere, and they're already shipping 2 nanometer chips to Apple and others. But the conversation has fundamentally shifted. What seemed impossible, advanced chips without EUV, is now merely improbable. And Huawei has a track record of making the improbable real. The 7 nanometer Kirin 9000s wasn't supposed to exist. The 5 nanometer equivalent Kirin 9030 defied predictions. This 2-nanometer patent might be the next chapter in that story. Or it might join countless ambitious patents that never escaped the laboratory. Either way, the semiconductor war just entered uncharted territory, and the next 24 months will tell us which future we're headed toward. Will Huawei crack the code that everyone said was impossible, or will physics and economics prove too much to overcome? Drop your predictions in the comments below, and subscribe to stay updated on the biggest technology war of our generation.
Huawei is very dangerous.
Rarely does a country go to war with a private company.
We have met the enemy, and it is Huawei.
We're not going to do business with Huawei.
Huawei represents a national security risk.
But is this really about Huawei, or is it something bigger than that?
In early 2025, a Chinese tech giant did something that sent shockwaves through Silicon Valley and beyond. Rather than renewing their Windows license, Huawei unveiled a revolutionary line of laptops that didn't just challenge the status quo, they completely rewrote the rules of personal computing. The centerpiece of this technological rebellion? The MateBook Fold, a device that makes your smartphone look chunky by comparison. When unfolded, it reveals an 18-inch OLED display so bright it makes professional monitors look like they're running on candlelight. At 23,999 yuan, it's not trying to compete on price, it's showcasing what happens when a company decides to break free from conventional wisdom. But the real story isn't about the hardware, it's about what's powering these machines. Harmony OS 5 represents the culmination of a journey that began as a defensive move against trade restrictions, but evolved into something far more ambitious. This isn't some rushed Windows clone. It's the result of 5 years of intensive development, more than 10,000 engineers, and over 2,700 core patents that fundamentally reimagine what an operating system can be in 2025. The numbers are staggering. Within weeks of launch, Harmony OS 5 supported over 150 applications, with plans to reach 2,000 by year's end. But it's how these applications work together that's truly revolutionary. During a recent demonstration, Huawei's AI assistant Celia transformed a 2-hour meeting into a comprehensive presentation within minutes, complete with action items and key insights, a task that would have taken hours on traditional systems. For decades, personal computing has been dominated by a powerful duopoly, Windows commanding over 70% of the market, with Apple controlling the premium segment. Now, a third player has entered the arena with something genuinely different. The security implications alone are sending shockwaves through government and enterprise sectors. In an age where data sovereignty has become paramount, Huawei's approach offers complete control over both hardware and software, a level of security integration previously unimaginable. The impact is already rippling through the industry. Component suppliers report dramatic shifts in procurement patterns, with specialized components creating entirely new supply chain dynamics. In Shenzhen's electronics markets, traditionally a bellwether for global tech trends, vendors are racing to stock Harmony OS-compatible peripherals. Rather than mimicking Windows or Mac OS, Huawei has created something that feels native to 2025. The interface adapts to your work style, learning from your habits, and optimizing performance in real time. Early benchmarks show these machines booting in under 8 seconds and delivering more than 15 hours of battery life under normal usage. The MateBook Pro, starting at 7,999 yuan, brings this innovation to a broader market. With up to 32 GB of RAM and 2 TB of SSD storage, it's designed to go head-to-head with established players. But it's the seamless integration with Huawei's broader ecosystem that sets it apart. Files flow effortlessly between devices, calls transfer from phones to laptops without interruption, and screens extend wirelessly to create immersive workspaces. The transformation is perhaps most visible in how these machines handle everyday tasks. During a recent demonstration at Huawei's Shenzhen headquarters, engineers showed how a single gesture could seamlessly move work between devices. A presentation started on a smartphone continued instantly on the MateBook Fold's expansive display, while real-time translation handled a multi-language video conference without missing a beat. The implications stretch far beyond personal computing. In Southeast Asia's bustling tech hubs, developers who once exclusively created Windows applications are now pivoting to Harmony OS. This shift is particularly evident in enterprise settings. At Asia Pacific Bank's headquarters, a pilot program replacing traditional workstations with MateBook Pros has reduced IT security incidents by 47% while cutting training time for new employees in half. The zero-trust architecture of Harmony OS 5, where every process runs in isolation and all data transfers are encrypted, has set new standards for corporate security. The timing couldn't be more critical. As Microsoft prepares to end support for Windows 10 in October 2025, millions of users worldwide face crucial upgrade decisions. Huawei's alternative arrives at a moment when businesses and consumers are actively seeking options that break free from traditional upgrade cycles and proprietary limitations. The response from Silicon Valley was swift but measured. Microsoft's CEO acknowledged the shift during their quarterly earnings call. Innovation comes in waves, and we're seeing a significant one emerge from Asia. But behind closed doors, industry insiders reveal frantic strategic meetings as Western tech giants grapple with this new reality. By September 2025, the impact became impossible to ignore. Huawei's Dongguan facility was operating at full capacity, churning out over 3 million units with plans to reach 5 million by the end of 2026. The developer community's response has been equally dramatic. Over 50,000 developers worldwide have flocked to Huawei's platform, creating specialized applications that leverage Harmony OS's unique capabilities. In Brazil, startups are pioneering AI-driven solutions that were previously impossible on traditional systems. Nigerian developers are creating educational apps tailored for local needs, while European firms explore healthcare applications that maintain strict privacy standards. At Shanghai General Hospital, the transformation is already visible. Doctors use MateBook Folds to access patient records and plan surgeries across multiple secure domains. The ripple effects extend far beyond China's borders. In Singapore's bustling tech hub, traditional Windows developers are pivoting en masse to Harmony OS. The platform's AI capabilities have sparked a creative renaissance, with applications that blur the line between mobile and desktop computing. Even European Union officials are taking notice, with Dr. Maria Schmidt, a senior digital policy advisor, noting, "This demonstrates that building an independent ecosystem isn't just possible, but it hasn't all been smooth sailing." DeepSeek, a Chinese AI startup, recently made headlines by switching back to NVIDIA GPUs for their heavy workloads, highlighting the ongoing challenges in China's semiconductor sector. Yet, rather than undermining confidence, this candid admission has reinforced Huawei's pragmatic approach to development, focusing on steady improvements rather than unrealistic promises. The supply chain implications are equally profound. This technological leap is perhaps most evident in the education sector. At Tsinghua University, computer science students have developed an AI-powered video editing suite that automates professional content creation, a task that traditionally required expensive, specialized software and extensive training. The security implications continue to draw attention. Traditional antivirus software becomes largely obsolete when every process runs in isolation and all data transfers are encrypted by default. Enterprise customers report dramatic reductions in security incidents, with Asia Pacific Bank's 47% drop in IT security issues serving as a compelling case study. The timing of this transformation is particularly significant as Microsoft prepares to end Windows 10 support in October 2025. Millions of users and organizations face crucial decisions about their computing future. Huawei's alternative arrives at a moment when the market is actively seeking options that break free from traditional upgrade cycles and proprietary limitations. As 2025 progresses, the impact on global tech dynamics becomes increasingly clear. Regions where Huawei already maintains strong smartphone market share, Southeast Asia, Africa, and Latin America, are witnessing the emergence of new business ecosystems. Local entrepreneurs are creating peripheral devices, developing specialized software, and building support services around this new platform. The most profound change may be in how people think about personal computing itself. The distinction between phones, tablets, and laptops begins to blur as Harmony OS creates a seamless experience across all devices. Real-time translation, AI-powered productivity tools, and intelligent security features aren't just add-ons. They're fundamental to how these machines operate.
Huawei is very dangerous.
Rarely does a country go to war with a private company.
We have met the enemy, and it is Huawei.
We're not going to do business with Huawei.
Huawei represents a national security risk.
But is this really about Huawei, or is it something bigger than that?
In November 2024, engineers at Apple and Qualcomm stared in disbelief at something that seemed to defy the laws of physics. A smartphone that could message satellites directly from your pocket. No bulky equipment, no special antenna, just a regular-looking phone that worked anywhere on Earth. This wasn't some far-fetched concept or prototype. This was Huawei's Mate 70, and it was about to turn the entire telecommunications industry upside down. Picture this. You're deep in the Yellowstone wilderness, miles from the nearest cell tower. Your hiking partner takes a devastating fall, breaking their ankle. In the past, you'd be completely cut off from help. But now, you simply pull out the Mate 70, and within seconds, you're sending emergency messages through satellites orbiting 550 kilometers above your head. While American tech giants were busy fighting over 5G coverage maps, China quietly orchestrated one of the most ambitious telecommunications projects in history. They launched 15 advanced satellites into precise orbits, constructed a massive ground station network spanning 3,000 kilometers, and somehow managed to compress all that connectivity into a device that fits in your back pocket. The technology inside the Mate 70 reads like classified military research. Huawei's engineers developed a revolutionary power amplifier chip that can boost a tiny smartphone signal strong enough to reach satellites moving at a mind-bending 27,000 kilometers per hour. They created an antenna system that tracks these satellites in real time, maintaining rock-solid connections even as they zip across the sky. Most impressively, the whole system operates with just 0.7 seconds of delay, faster than many regular international phone calls. But the true genius wasn't just in the hardware innovation, it was in the timing and strategy. While the United States was trying to cripple Huawei with export controls and tech bans, the company was secretly building an entirely new communication infrastructure. Think about traditional cellular networks. They require massive infrastructure investments, cell towers every few miles, endless miles of fiber optic cables, power systems, and maintenance crews. In rural Africa, telecom companies spend millions trying to connect single villages. In Alaska, whole communities go without reliable service because building towers is simply too expensive. Huawei just made that entire model obsolete. One satellite can cover an area the size of Texas. A constellation of them can blanket the entire planet. The numbers tell a stunning comeback story. In the third quarter of 2024, while still under crushing U.S. sanctions, Huawei shipped over 10 million smartphones in China alone, climbing back to become the country's second-largest phone manufacturer. The Mate 60 Pro, which first pioneered this satellite calling technology, became such a symbol of national technological pride that Chinese consumers lined up for hours to buy one. But this is bigger than just Huawei. China's Tiannong satellite network, originally built for government and military use, has now opened up for civilian applications. China Telecom's Tandy Wing card service allows any compatible phone to connect to satellites for voice calls and data. The infrastructure is already in orbit, silently waiting for millions of users to come online. This breakthrough comes at a crucial moment in history. Natural disasters are becoming more frequent and severe. Remote work is pushing people farther from urban centers. Traditional cellular networks are struggling to keep up with demand while facing massive upgrade costs. Huawei just offered the world a way to bypass all these problems entirely. The real-world applications are already proving transformative. Reuters correspondents successfully sent high-resolution photos through the Mate 70's satellite connection from the middle of the Gobi Desert. Maritime shipping companies report crews maintaining constant contact with family throughout Pacific crossings. Most remarkably, rescue teams in Sichuan province use the technology to coordinate earthquake relief in areas where traditional networks were completely destroyed. The consequences of Huawei's breakthrough rippled through the global technology industry like a shockwave. Within weeks of the Mate 70's launch, major U.S. carriers watched their stock prices tumble as investors grappled with an uncomfortable reality. Hundreds of billions invested in 5G infrastructure could become obsolete faster than anyone imagined. The impact was particularly dramatic in developing nations. In February 2025, Kenya announced a groundbreaking partnership with Huawei that would save the country an estimated $12 billion in cellular infrastructure costs. Instead of building thousands of cell towers across challenging terrain, they could provide nationwide coverage immediately through satellite connections. Within months, 12 other African nations had signed similar deals. But it wasn't just about cost savings. When devastating floods hit Southeast Asia in March 2025, rescue teams equipped with Mate 70 phones coordinated life-saving operations in areas where traditional networks had been completely destroyed. Meanwhile, Huawei's recovery in its home market continued to accelerate. The company's in-house chip manufacturing capabilities, developed under intense pressure from U.S. sanctions, were now producing semiconductors that rivaled anything coming out of Taiwan or South Korea. Their Harmony OS Next operating system had grown to support over 20,000 applications by early 2025, making it increasingly viable as a true Android alternative. But perhaps most remarkably, Huawei had achieved something that eluded even tech giants like Apple and Google. They had made satellite communication feel completely normal. Users reported seamless switching between cellular and satellite connections, with many not even realizing when they were messaging through space rather than traditional networks. The technology's potential to reshape global communication patterns became evident in unexpected ways. Remote workers began relocating to previously unthinkable locations, knowing they could maintain reliable internet connections from anywhere. Digital nomads posted viral videos of crystal-clear video calls from Mount Everest Base Camp. Ships at sea reported constant connectivity without expensive maritime satellite services. Chinese authorities capitalized on this momentum by rapidly expanding the Tianong satellite constellation. By mid-2025, they had launched an additional 10 satellites, creating even more robust coverage. The network's civilian capabilities were enhanced through China Telecom's Tandai Wing Card service, which allowed any compatible device to tap into satellite connectivity. The speed of these developments left Western tech companies scrambling to catch up. Apple reportedly reassigned hundreds of engineers to accelerate their satellite communication projects. Samsung announced partnerships with multiple satellite providers. But they faced a daunting reality. Huawei's years of forced self-reliance under sanctions had given them a nearly insurmountable head start in key technologies. Even more concerning for Western officials was China's growing influence in global telecommunications. As developing nations signed deals for satellite-based infrastructure, they became increasingly integrated into China's digital ecosystem. Traditional diplomatic leverage through control of physical network infrastructure was rapidly eroding. What began as a surprising product launch had evolved into something far more significant, a fundamental reimagining of how humanity connects across the planet. As 2025 progressed, it became increasingly clear that Huawei hadn't just created a new type of phone. They had quietly revolutionized global telecommunications while the rest of the world was looking the other way. 300,000 AI chips. That's the staggering order China just placed with Nvidia, sending shockwaves through the global technology industry. But behind this headline-grabbing purchase lies an even more remarkable story that's making Silicon Valley executives lose sleep. Inside ByteDance's heavily guarded research facilities, engineers have been pushing a new Chinese chip to its absolute limits, and the results are rewriting everything we thought we knew about the global AI race. The Huawei Ascend 910C isn't just another semiconductor. It's a technological breakthrough that wasn't supposed to be possible.